Alright, so we're going to be reviewing some of our key vocab terms and notes. Alright, we're going to be talking about arithmetic versus geometric. So when we know arithmetic is our adding or subtracting. So this is adding or subtracting. So arithmetic is adding or subtracting. We know that D, so D represents the common difference. So that's the common difference. So we have arithmetic, it's our adding, subtracting, D's our common difference, and then we can get our recursive equation. So we just need to know the formula for arithmetic, for the arithmetic recursive equation. We always start with f of 0 is the initial value. So that's our initial value. And then we know that f of n is equal to f of n minus 1 plus the d. So it's equal to the previous term plus our common difference. So that's the recursive equation. If you need time to stop, pauses to copy everything down, that's perfectly fine. So you have the chance to stop and pause and then take your notes. And then we have explicit. So the explicit equation, so our explicit equation is f of n equals f of 0 plus d times n. Well, we're going to be able to figure out what f of 0 is, and we're going to be able to figure out what d is. So it's going to be d times n. And then we also talked about finding the missing sequence, missing number in a sequence. So finding the missing sequence. And that is where we have our first value. So it's the first value plus the number of our changes. So it's plus the number of changes, or that's the number of d's times d, and that equals the last value. Now what we can do here, if we can make an example. So I'm going to make an example here. So what if I actually just make this a little bit smaller so I can fill in my example here. So we just made it a little bit smaller. So now my example, so with this example, and I'm just going to make my paper a little bit bigger here. Give me a little bit more room to write. So for my example, if I make a table, so I'm going to make my table, my x, my f of x. So if I have 1, 2, 3, 4, 5, 6. So I have my table here. And then the table, I'm only going to give myself the value of 8 and this value of 23. So what we need to do is we can find all of these, our recursive equation, our explicit equation, the missing value. Or we just have to start and find the missing values first to find the d. Then we can get our recursive equation, which will give us our explicit equation. So what we want to do here is the first thing, alright, we start at 8. So if we start at 8 plus, now we have 1, 2, 3. So that's going to be 3 changes, alright, times d, because we don't know what d is, and it's going to equal our last value. So we're starting at 8, we're changing it 3 times to get to 23. So that's how we're going to figure out what d is. So now we can subtract 8. So 3d is equal to 15. Divide by 3. and D is equal to 5. So we know that our changing, it's adding each time by 5. So we do 8 plus 5, that'll give us 13. 13 plus 5 will give us 18. 18 plus 5 is 23. 23 plus 5 is 28. And then, well, f of 1, well, we're going backwards, so instead of adding 5, we're subtracting 5. So 8 minus 5 is 3. So that's how we can figure out what our common difference is. Now, with our recursive equation, so the recursive equation, in this example, we need to know what f of 0 is. So f of 0. We know that when x is 1, f of x is 3, but we want 0. So we actually have to go back one more. So when x is 0, we go back 3 minus 5 is negative 2. So f of 0 is negative 2. Then f of n equals f of n minus 1. And then plus our d, so that's plus 5. So that's plus the d, which is 5. And then our explicit equation, well, it's f of n equals f of 0. Well, f of 0 we just established is negative 2, plus, because we're adding, so we're adding 5 each time to the number. So we get negative 2 plus 5n. So that is how we get our explicit equation. Now that's all with our arithmetic sequence. And then we have geometric. Well, we know that geometric is multiplying or dividing. And geometric is also, we have r, which represents the common ratio. So now we have a different letter, so r is our common ratio. And one thing we need to remember about geometric is dividing. Dividing is the same thing as multiplying by 1 over that number. So if we're dividing by 5, it's the same thing as multiplying by 1 over 5. So whatever we're multiplying by that number, 1 over that number. So we have our recursive equation for geometric. So the recursive equation, once again, we have f of 0 equals our initial value, f of n. Now this time, geometric is multiplying, so we have our r, which is our common ratio, times f of n minus 1. So it's times the previous term. So our ratio times the previous term. And then we have our explicit equation. Our explicit equation is f of n equals f of 0 times r to the power of n, however many times we're going to do it. So we'll figure out what f of 0 is, and then we multiply it to r to that power. And then if we want to find the missing sequence, to find the missing number in a sequence, missing terms, to find our missing terms in a sequence, we simply have our first value, so whatever the first value we have, and now this is times, because we're multiplying, times r, that's our common ratio, which is what we're looking for, to the number of changes, so however many times it changes, and that equals the last value. So it equals the last value. So if we take a look at a quick example here, hopefully you still have a lot of room on your paper. So our example, so if we have our table, we have x, f of x, and we have 1, 2, 3, 4, and 5, and I say that we have 16 is right here and 256 is right here. So once again, we can, given a table, we can find the missing terms in our sequence, get our recursive equation, and then write the explicit equation. So once again, first value is 16, so we say we have 16 times the number of changes. Now the number of changes from 16 to 256 is 2. So we have 2 changes. I don't want that. I want to actually, I'm going to cross off 256. And I want to actually change that to 1024. So we're going to change 256. And we're going to say this is 1024. So we don't have 2 changes, we have 3 changes. So this is r to the third, because we have 3. 1, 2, 3 changes, and then it's going to equal 1024. So we're going from 16 to 1024, and we have 3 changes in between. Now we divide by 16, so r to the third power equals 64. And what we want to do is we want to take the cubic root of this. So the cubic root, and that's where I showed you to do it in the calculator, where we type the number 3. Then we go to math down to number 5, and then we type in 64. And the cubic root of 64 will give us 4. So r is equal to 4. So 4 times 4 times 4 will equal 64. Okay. And now, let me just cover this back up. Now we can fill this in. So 16 times 4 is 64. 64 times 4 is 256. And then to go back to 1, well, we're multiplying by 4, so we go backwards. What times 4 will give us 16? Well, 16 divided by 4 is 4. To write our recursive equation, so to get the recursive equation, our recursive equation, so we have f of 0 equals, well, we don't see 0 in here, so we actually have to go back to 0. So if I go back again, dividing by 4, so that's going to give me 1. So f of 0 is going to equal 1. And then f of n equals f of n minus 1 times 4, because that is the r. And then our explicit equation, and we could have wrote 4 times f of n minus 1, alright, and thus the explicit is f of n equals f of 0. Well, f of 0 is 1, so it's 1 times our r, our common ratio, which is 4 to the power of n. So that's how we get our explicit equation, our recursive equation, and we find out what the value of r equals. So now we have arithmetic sequences and we have geometric sequences. And then if we just look at this one in the back real quick, so it says to find the missing values, alright, we have to determine if this is arithmetic or geometric. So if we look at this first one, well, this is adding by 8 each time. So this is arithmetic. So we know that this is arithmetic. Determine the explicit equation. Well, explicit equation is f of n equals f of 0 plus d times n. So f of n equals f of 0. Well, when x is equal to 0, f of x is equal to 16. So 16 plus d, our common difference, is 8 times n. And now we can just plug the value in. So we have our equation. And now we just plug 25 in for n. So f of 25 is going to equal 16 plus 8 times 25. 8 times 25 is 200. 200 plus 16, 216. For b, f of 100 is going to equal 16 plus 8 times 100. So 8 times 100 is 800. 800 plus 16 is 816. Now for this one, it says f of x equals 176. Well, we're just going to take our equation. So we're going to say 16 plus 8n equals 176, and then solve it. Minus 16 minus 16. 8n equals 160. Divide by 8. So n will equal 20. And then the same thing here. F of x equals 656. We take our equation. 16 plus 8n equals 656. Subtract 16. 8n equals 640. Divide by 8. N is equal to, goes into 8, 0. N is equal to 80. For the number 2, when we look at this one, this is multiplying, so it's times 4 times 4 times 4. So this is our geometric. So once we know it's geometric, we can write our explicit equation. So f of n equals f of 0. Well, when x is 0, f of x is 2 because 2 times 4. So 2 times r, which is 4, so we know that r equals 4 to the power of n. So we have our explicit equation, and now we just plug this in. So f of 10 is 2 times 4 to the power of 10. So 2 times 4 to the power of 10. And 4 to the power of 10 is 104,8576. So 1,048,576. And we multiply that by 2. So we have f of 10 equals 2,097,152. And then for b, it tells us what it equals, so we do 2 times 4 to the n equals 131,072. To solve this, we divide by 2. Divide by 2. So we have 4 to the n equals 131. 6,500. So 4 to what power will give us 6,536. Well, we can figure out, well, 4 to what power? We can determine, well, what, if we break this down, it's going to be 4 to the what power? So if we divide it by 4 until we get down there, we will figure out that this is going to be 4 to the let's see. This will break down to 4 to the 8th power, so 4 to the n equals 4 to the 8th. Same basis, n is equal to 8. And that's how we set this one up and solve it. So that's how we find these values for our functions. And then that's our geometric versus arithmetic sequences and all of our notes.